So hi friends. So in this video, I'd like to talk about the memory layout, or we can say it's a memory alignment for any user-defined data type. So user-defined data type is nothing but like a structure or the classes. We can say anything which creates the any data members. We build our user-defined types with the various data members. Okay. So as per this example, you can see I create one structure. The name of the structure is it's a st, and I have two data member. Okay, one is char type. It's called index. Another one is in32, which is basically it's a 4 bytes integer, and the name of the integer is it's a id. Okay, so basically it's just a two-member variable structure. So by reading the code, okay, so what we predict, the prediction is it's totally the size of the structure is 5 bytes, right? Because basically char it's a 1 byte, we all know that, and integer it's basically it's a 4 bytes, right? It's a 32-bit, so it's a very clear, it's a 4 bytes, it's 1 byte, it's a 4 bytes. So totally we can say it's a 5 bytes of structure, right? By reading the code, but that's not the truth. Actually, the size is it's 8 bytes. Yes, the size is 8 bytes. It's because of the padding. Okay, so it's based on the hardware. Okay, it's purely based on the hardware. How the memory layout should be for our user defined type. Okay, it can be more. Okay, it cannot be the less. It's not like a 4 byte integer cannot be considered as 3 bytes. Okay, here the char it's a 1 byte, but actually it's adding three more bytes into it. That is called padding. Okay, I will explain with the memory layout how instance of this structure, S3, how the memory representation is. Okay, for the structure st. Okay, so it is initialized with for this both the member, one for char and another one for integer. So let me move, and I'm just using the pointer which referring to the address of a, which is nothing but the starting data member address, right? So address of a it's equivalent to the address of index. It's both the same. Let me move it over here. So let me get the address of this pointer. What is the exact address? Okay, so okay. So you see here, the starting address it is referring to 61, which is nothing but it's a the value of a, right? So basically, as per the ASCII table, the ASCII value for small a is 61, and you see here, I use the integer. It's actually it's 11, right? 11 is nothing but it's a hexa. It's everything is hexa. So 9 till 9 it's 9 and 10a and b. 11 is b. So you see here, the starting addresses, it's let's assume this one 0 byte, but the next integer data member starts with 0 plus 4. So this is called a padding. So we are including the padding concepts here. So to be more precise the example, okay. So let's say I'm using the reinterpret casting to dereference the value of the address A. Okay, so you see here address of A is nothing but same, right? Address of A is same. It's same. It's referring to 61. So if I dereferencing that pointer, okay, I can get the value A. Okay, I can get the value A. Now, if for assumption, okay, so now we know that we have added the 3 bytes of padding, but let's assume that we understood that it's just a 1 byte, and the next byte it's actually storing the next byte, right? So the next byte of a1, if I do a1 plus 1, it's just incrementing 1 byte. Okay, so this is a58. So if I increase 1, ideally it is 59, right? So 59 referring to cc. Let me move here. Okay, you see here what is this is referring to. You see here it is referring to cc. That's the problem actually. You see here, that's a problem, because a1 it's still referring to the char type. Okay, when we do the increment operator, okay, it's exactly true, we are iterating one byte, that's fine. But actually our integer data type, the next integer data type present plus 4. Okay, so if I do that something like this, we know that 59, then I can say it's 60. No, sorry, it should be 59, right? It's 59, then it's 59a. Okay, it's 2a, it's b, it's c. You see here, so we have to use a1 plus 4, a1 plus 4 to access the integer data type. Okay, so guys, I hope you can understand this problem. So padding is very very important and you should understand very well before you are reinterpreting, or if you are accessing the data member individually, so you should know how it's stored. Okay, so that's why usually the reinterpret casting is quite dangerous, because it's a purely based on the hardware. Okay, it's purely based on how the hardware stores our data. And I would be giving one more extra points. Okay, if you're using the reinterpret cast to access this integer, yes, you have to use this a1 plus 4. Okay, because 1 byte for the actual value for the char type, remaining 3 bytes for the padding. So this is fine. This is C++ style casting, right? C++ style catching. But you know one thing, we can use, let's say this is PPTR. If you use a C style casting, okay, if you use C style casting, this will work. Okay, the magic is why this will work. This will provide the exact value of 11. The difference is C style, the casting, okay, casting works based on the this whatever the data type is referring to. So a1 plus 1 means 1 byte. Here it's referring to, here 1 is referring to the address of this data type. Okay, so it's basically it's converting something like a1 plus 4. It's because of the integer type. Let's say if you are using float, okay, it's converting into, again it's a 4. Let's say if it is double, okay, the 1 byte referring to 8, it moves 8 byte position. So that's why the C style casting straightforward works for you, but reinterpret cast will not working, because reinterpret casting works based on the expression we are providing it. So a1 is scared, so if you are providing 1 here, it just to move a1 plus 1, it just to move to the next byte. Okay, so that is the actual difference between the reinterpret cast and the C style casting. Okay, so the objective of this video is like, guys, the padding concept is very very important to access a member variables in straight away. Okay, thanks guys, thanks for watching this video. Please do subscribe my channel and don't hesitate to add your feedback, because I'm trying to share the programming knowledge and engineering knowledge as much as possible from my side. So during my available time, I'm trying to post it. Okay, so don't hesitate to add your feedback, like whatever that you want me to provide the comments, like what area I can be improved better, and video editing, because I'm doing everything myself and I don't pay anyone else for the editing purpose. Okay, so just let me know if it can be improved in better way, which can be helpful for you more. Okay, thank you, thanks again guys. Thanks guys, thanks for watching this video. Please do subscribe my channel and don't hesitate to add your feedback, because I'm trying to share the programming nudges and engineering nudges as much as possible from my side. So during my available time, I'm trying to post it. Okay. So don't hesitate to add your feedback, like whatever that you want me to provide the comments, like what area I can be improved better. Just let me know if it can be improved in better way, which can be helpful for you more. Okay. Thank you. Thanks again, guys.